Let's take a look at exit slip 20. This is our last exit slip. So in this exit slip, we were looking at nonlinear systems. So basically that meant that at least one of our equations in the system of two equations, two variables was not linear. So it could be quadratic or even something like a circle or an ellipse. So in this case, it looks to us like we've got one, a quadratic equation of sorts in our first equation, and two, a linear equation of sorts in our second equation. So a nice technique for solving a nonlinear system of this type would be to take the linear function and solve it for the variable that's not being squared in the first equation. That'll make the solving just a little bit more straightforward. You don't have to do it this way, but I would probably prefer to isolate y by adding x to both sides, so that anytime I see a y in the first equation, I can simply replace it with x plus 2. So let's try doing just that much. Rewriting the first equation. Anytime we see a y, we insert x plus 2. So when we do that, we end up with this quadratic equation. I'll subtract 2 from both sides to get x squared plus x equals to just 0. And looks like a good technique to finish solving this would just be factoring. X squared plus x share a common factor of x. Removing that factor gives us x plus 1. So we can see either x is equal to 0 or x is equal to negative 1. The thing about nonlinear systems is we need to be very careful to track an x with its respective y solution. So all I mean by that is, at this point, I need to find the y that corresponds to x being 0, and then separately I need to find the y that corresponds to x being negative 1. So to find these y values, let's just go back to this substitution equation. So if x is equal to 0, y becomes 0 plus 2, or just 2. And if x is negative 1, y becomes negative 1 plus 2, or just 1. So as we write these two solutions, we'll just be really clear to write them as ordered pairs. The first solution is when x is 0, the corresponding y is 2. And then our second solution was when x is negative 1, the corresponding y is positive 1. So we get 0, 2, and negative 1, 1. And I would definitely encourage you, if it were me, I would think about the graph to make sure this made some sense to me. Rather than going out to Desmos, I'll just do a really quick freehand sketch for you. It looks like the quadratic would have been y equals negative x squared plus 2. So that means it's a downward facing parabola shifted up by 2. So I'll give you a rough sketch of that graph. And then the linear function, y equals x plus 2, has a slope of 1 and a y-intercept of 2. So let's see, if I pass through 0, 2, I could go down by 1, left by 1. So here would be the linear function. And again, I'm graphing by hand, so it's a little far from perfect, but you can basically see that we have that solution of negative 1, 1. So that seems logical right here. And then we've got that solution of 0, 2. So check it out graphically. It's always a good idea. And that wraps up college algebra. Congratulations on completing our class.